Ladies and gentlemen, welcome to another question. So now we are going to look at how to solve this kind of questions. So today we have these questions which says that a first order reaction has a rate constant of 3.00 times 10 raised to the power of minus raised to the power of minus 3 per second, and the time required for the reaction to be 75% complete is, and we have option A 95.8 seconds, and we have option B 462 seconds. Option C is 201 seconds, while option D is 201 seconds. So ladies and gentlemen, we have equation of first order, second order, and zero order, and we need to look at it very well before we solve this. So now let's look at this. So these are the summary of the kinetics of the zero order, first order, and the second order reactions. So for the rate constant, or for the rate law of the order reaction, rate is equal to K. It means that the rate of the reaction, it doesn't depend on the concentration of the reactant. And of course, the equation for the first order reaction is concentration of A is equal to the initial concentration of A minus Kt, and the half-life is initial concentration all over Tk for the zero order. And for the second order, we have, for the first order, we have R is equal to K times concentration of A, where the equation represents the concentration of A is equal to ln initial concentration of A minus Kt, and the half-life is equal to ln 2 all over K. And of course, for the second order reaction, we also have the equation here for both the both the equation and of course the half-life. So for the half-life, 1 is equal to 1 all over K times concentration of A naught. So now this is the first order. If we look at our first order questions from the previous slide is on the first order reaction. So what are we going to do now? So let's go back and solve it. So we are now going to use this equation. So ladies and gentlemen, it's important to know all this equation. So now let's go back and look at how we are going to solve the equation. So now let's now get the formula. So the formula is ln A. The formula is ln A, and we close brackets, and is equal to ln A naught minus Kt. So of course, the concentration used of, that is ln E, and of course the initial concentration minus Kt. So I think the first thing here, let's make the T subject of the formula here. So you can make T subject of the formula. So you can take Kt to this side. Then we now have ln A naught minus ln A. And of course, this one can simply change. Remember, according to the theory of logarithm, ln can also, so the minus can also be divided, can also change to division. So Kt can also be equals to ln A naught all over ln A. So we have ln A naught. So of course, we have our K here, which is 0.00 times raised to the power of minus 3. So we now have, okay, so I think we can just start with this. So we have Kt is equal to ln A naught all over A. So since here we're talking about 75%, it means that the starting concentration of the reactant is 100%. Is 100. And then how are we now going to know okay, here is So how are we now going to know the exact amount of the reactant that used off? So this is A, that is the final concentration that is used. So we are now going to say, so for you to know the final concentration that is used of, then we are now going to say 100 minus the 75%. So minus 75. And now we're going to have 100 divided by, so we have 100 minus 75, so we have 25. And of course, 100 divided by 25, it's going to give us 4. So we now have KT is equal to ln 4. So we now have ln 4. So therefore now, so we have now KT is equal to ln 4. So of course, we are now going to press our calculator and get exactly what ln 4 is. So let's see the value for ln 4. So ln 4 is the same thing as 1.3863. 38 is the something as 38, something as 1.38386. Okay, what is the problem? Okay, it's 386. So it's going to be 386. Comment, let me check and see. Of course, I think since we said here is we have KT is equal to ln 4. So we can take it here. We can now say because it's T that we want to get, so we can now say T is equal to ln 4 is equal to ln 4 divided by the K. So of course, our ln 4, if we press our calculator, the ln 4 is going to give us 1.3863 give us 1.3863. So 1.3863 divided by K. So what is the value of our K? Is 3 times 10 raised to the power of minus 3. So we have 3 times 10 raised to the power of 3. So if we now take this and divided by 3 times 10 raised to the power of minus 6, it is going to give us 462 seconds. 462 seconds. Which means that the answer is option B. So thank you, ladies and gentlemen. If you have any questions, you can ask on the comment section, and I hope this video will be of help. Thank you.